Hi everyone, this is the video explanation to the problem posted on the website a few days back. For those of you who haven't yet looked at the problem, the link is there in the description. So the problem goes as follows. We have 4 knights in a 3x3 chessboard, 2 black knights and 2 white knights. We need to move them from positions in the state 1 to positions in state 2. To make it clear, a knight moves 2 steps in one direction and 1 step in its perpendicular direction. So it could be in either of these ways. So from its position here, it could move to all the positions shown with a cross. If you would like to think about the problem before looking at the solution, I would recommend you to pause the video here. One way to go about the problem would be to randomly try and move the knights and try to see if we can reach state 2. Another way to think about this could be to mark all the squares with numbers from 1 to 9 and draw out the possible connections. A knight in square 1 could move to position 8 or to position 6. So a knight in state 1 can be connected to 6 or could be connected to 8. Similarly, a knight in position 6 could move to either 1 or 7. So a knight in position 6 is connected to 1 and 7. All these possibilities can be shown by a connected graph. If we draw all the possibilities, this is what we finally get. Now all the positions on a chessboard can be represented by this graph and the moves can be replicated here. This is how our initial positions on the chessboard would look like on this connected graph. Now let's say a knight in position 1 moves to position 6 and a knight in position 3 moves to position 8. So this is what our board would then look like. Similarly, we can replicate any state or movement of the knights on the connected graph. This is what our initial and desired final positions look like. This is how they would look like on the graph. We can try to figure out a way to move the knights from state 1 to state 2. What we see here is that a shift from state 1 to state 2 would require a reordering of the knights. From white, white, black, black, we would need to go to white, black, white, black. The reordering would be possible only if 2 knights were allowed to be at the same position at some point of time. For example, if the black knight at position 9 wants to cross over the white knight at position 7 in order to move between the 2 white knights, it would have to be on the same position as the white knight at some point of time. But since it's not possible to have 2 pieces on the same position at a given point, we can say that it's not possible to reorder the knights. This is a very simple example of how a connected graph can help us think simply about seemingly complex situations. So we can conclude that it's not possible to move the pieces from the first state to the second state here. For more interesting problems and mathematical ideas, you can visit loveformath.com.